Alright guys, let's take a look here at Earthlink Direct Exchange, which I consider to be easier for retrofit. You don't have to have it included in initial construction, so you can come back and retrofit existing houses or buildings. And it just seems to be not as primitive. You don't have to move as much earth, and I think probably more cost effective in that respect.
It is more efficient. It is better for the environment. You will save money. It will last longer.
So you remember our geothermal radial drilling, GRD, back, I think it was in Unit 6, Topic 6. Here we go.
Where do we find a constant, inexpensive, environmentally friendly source of comfort without burning fuel or recycling outside air? The answer is right beneath our feet. The heat stored in the earth is readily accessible for transfer directly into and out of buildings for heating and cooling. Now, ECR Technologies' Earthlinked heat pump and direct access earth loops are the simplest, most direct method to access the renewable energy of the earth. The secret of the Earthlink system is ECR Technologies' direct access earth loops and refrigerant flow controls, which allow refrigerant to exchange heat directly with the earth. This means that an earth-linked heating and cooling system will save more money, be more efficient, and will be better for the environment. Why use the earth as a medium for heating and cooling your home? All heating and cooling systems condition your home or office by exchanging heat in some way. A conventional air conditioning system, for example, takes the outside air and draws it across refrigerant coils to take heat away from the refrigerant. In the summer, this means your air conditioner uses hot outside air up to 110 degrees, and that means your compressor is working vigorously to cool those refrigerant coils so you can stay comfortable. With an earth-linked system, the direct access earth loops are buried underground. The refrigerant is cooled by exchanging heat with the earth. The advantage is the Earth's temperature ranges between 40 and 75 degrees, even in the summer. The refrigerant compressor cools more efficiently, saving electricity. And what about winter? Does an Earth-linked system offer similar advantages as a heating system? The answer is yes. A conventional heat pump uses outside air to transfer heat. This outside air can be below freezing in many cases, and that means your heating system is using more electricity to provide heated airflow into your home or office. With an earth-linked system, the direct access earth loops are used to exchange heat from below ground. Using the Earth's constant ground temperature, heat is put back into the system, and then ECR Technologies' Earth-linked heat pump transfers that energy into comfortable airflow. According to the U.S. Environmental Protection Agency and the Department of Energy, because they use the Earth's natural heat, geothermal heat pumps are among the most efficient and comfortable heating and cooling technologies currently available. And independent studies by electric utilities have shown the Earth-linked direct exchange systems are as much as 25% more efficient than other water source systems.
Today we're installing an Earth-linked direct exchange heat exchanger. Starting out today, we had to come out and dig the manifold pit, which is basically the pit that we set the rig up around to drill in a fan pattern. We use what's called a D4 earth loop. A D4 earth loop consists of 4 50-foot loops per ton. As you can see in this job, we have a lot of landscaping that we have to work around. But with the rig that we have available and the small bore drilling, it makes it possible to retrofit.
So you picked up on that 4 50-foot loops per ton. So, 200 feet as opposed to 600 feet, probably because he's not dealing with cancellation.
Almost any job. Our refrigerant lines have to be a minimum of 6 feet below the surface of the earth, where the earth temperature is constant throughout the year. This particular application, we're using a diagonal loop system. The loops are 50 feet in length and they're drilled at a 45-degree angle, which puts them about 35 feet below the surface of the earth. In a direct exchange system, the loop is actually the refrigerant tubing in the system. That tubing has to be inserted into the earth, and it's essential that it makes contact with the earth for maximum heat transfer. In order to do that, after the loops are inserted in the hole, we grout that with a plasticized cement. That ensures that we have 100% contact around that loop for maximum heat transfer. A standard air source system uses an air-cooled condensing unit, and it's essential that that unit is located where there's sufficient air circulation. Since our cooling medium is the earth, there's no airflow required on the outdoor section. So our compressor unit can be mounted in an equipment room, equipment closet, garage, up in the attic. It's very versatile. It can be mounted almost anywhere. The distance from our compressor unit to the manifold has a maximum length of 125 feet, which also allows us to go just about anywhere. This is a good example of the versatility of our air handler. Our air handlers come in both horizontal and vertical positions, upflow and downflow. They can be mounted in the attic, they can be mounted in a garage or a service closet. As you can see, it would be hard to tell where the manifold pit was before we went back in with our landscaping. Also, the unit is about half the size of the air source system because the condenser is now located in the ground. We started this system when the outside air temperature was 110 degrees outside. Under those conditions, an air source system would run about 315 psig, that's pounds per square inch on the gauge pressure. Because the heat sink is in the earth at 64 degrees, the pressures when we started this up were 215 pounds per square inch gauge pressure. That pressure difference is a direct relationship to the reduction in power that this system uses. Because of the power reduction, you'll save about 30 to 70% on your utility costs. As you can tell, the most obvious difference between the Earthlink compressor unit and a standard air source condensing unit is no fan motor. Because of not having a fan motor, we use no electricity for that, and as you can tell, it's very quiet. For the air conditioning contractor, the installation of the DX system is really no different than what you're doing right now. The only difference in the installation is the ground portion of the system, and that's installed by a subcontractor or your drilling contractor. The drilling contractor will come out and dig your manifold hole, drill the holes, insert your loops, grout the loops, and then you take it from there. The primary benefit of the direct exchange system to the end user or the homeowner is that the system is 30 to 70% more efficient. That difference in initial cost can be made up in approximately 5 to 7 years. Everything after that period is money in the bank for you.
The Earthlink system is...
So notice 5 to 7 years on the recovery of the added cost, and that's with a retrofitted system with moving air. If you went to radiant, you get even better results.
Simply the most efficient way to heat and cool your home or office. It does it by using the renewable energy stored in the earth. What could be better for the environment? What could be better for you? Save money. Be more efficient. Be better for the environment by installing an Earthlink system for your home or office today. Contact ECR Technologies or visit us on the World Wide Web at www.ecrtech.com.